Hello everyone, it's your boy, that guy. This is How to Coding. Back at it again with that pink sweater. um, this week has been incredibly busy, so I apologize. I kind of missed the whole upload a video thing, record and upload a video thing. Let me just hold on, just wait like a stick. Just wait like a stick. Oh, my mic isn't centered in the frame. Just. Try and get centered in the okay, whatever. I love to, while I speak, look at the pretty stars. It's like my all-time favorite thing to do. That is written, that stars you're seeing there, that's written in OpenGL C++. The original the way it was built was with a Win32 GDI, but that was slightly too slow for what I needed, because it's all software based. It's software blitting, software rasterization, software 3D calc, all CPU based. So I changed over to relying on the graphics library that interfaces with the hardware. It's like my favorite thing. I'm a big fan of screensavers and all this kind of things, live wallpapers. So I found this like hack that gets me a live wallpaper that I can render my own screen buffer content onto the desktop. It's amazing. It's like my all-time favorite thing. I'll do a video on that at some point, but for now, let's continue. I think the last time we did tutorial 3, we got I don't know what we got. CPP blocks. Yes, let's see what we got. I think we had like a pedal on the screen, maybe keyboard input. I don't know. I know we had something, just not sure what. Oh, that's nice. I like how the game has like this weird challenge mode in it, right? Were we able to bounce off the paddle? Were we able to bounce off the paddle? I don't think we had that. Okay, we didn't have bounce off the paddle. Okay, fine, fair enough. I don't like this mouse control. It's a bit sloppy for my taste. We can bounce off the paddle. Excuse me while I drink some transparent drink. If any of you have seen my last videos, I have this like, oh, here we go. It's this blue tumbler. It's like, it's almost the same color as my screen, so you'll see like there's some points where there's like a shadow on it, and it becomes transparent. So the running gag is like, I'll drink from my transparent cup. I actually have a transparent cup, but it's not as funny, right? So I'll drink from my transparent cup. Just water. I don't usually speak much, so my throat becomes dry. I really dislike this mouse thing. Like I don't like it. I want to use the keyboard to control that thing. I want to up the speed a little bit. This slow thing, it just doesn't feel responsive. So I want to change this to. Oh my god, there's so much going on here. Sorry, it's become kind of. Oh, we had an auto brush. We had a simulation. The simulation is just the game that we're building, and we had some mechanics for updating the pedal and some mechanics for updating the ball. You know, I thought about this. I thought like we should do an ECS to get this working, but it's so much work doing a decent ECS. I'm not saying getting into the component system up and running is like so much of a schlep, but getting a decent one up and running requires lots and lots of thought, lots of fine tuning. It would be better off, it would be more beneficial for all of you if I just wrote the code off screen, came back and recapped it quickly. But I still feel like an ECS, an entity component system, for something as straightforward as move a block around on the screen. It just feels like overkill to me. But what I do want to do is I want to create some kind of inheritance model that has it gives us the ability to collide things into each other. And the reason I want to do colliding is I want to be able to define collision structures, something like I want a collision loop. Right now that we've got a little bit closer to the hardware, we don't have the overhead of whatever the browser is trying to do and the plugins running in the browser. We just got a bare bones. You got the OS, you got your compiler, whatever, that's IDE just runs in the background. It doesn't really consume much. You got your programs that run in the background, but the scheduler on the OS itself is much faster than the scheduler on a browser. So it would make sense that you've got a lot more speed or a lot more hardware backing, or I'm just going to call it time slice on the CPU. You got a lot more freedom of time slice because you're not sharing your time slice with the browser, with the controlling program. Your time slice is just like straight bam in the OS says, here you go, here's a piece of the actual raw CPU. You're not sandboxed like you are in the browser. So I wanted to a collision system, but I really want to think about it before I do anything. So the first thought that was just like kind of sketch it up in Paint. And is that 100%? The idea would be that let's get nice pretty colors. Oh, I love this. You've got this thing, right? It's called a collidable. A collidable object is basically just a screen representation of a sprite with a collision rectangle. Now, luckily, everything in this game is a rectangle, so it's like fairly straightforward. But the idea would be that you'd have this class, this collidable class, right? And then underneath this class, let's just do it in a different color. You would have a bunch of other things that inherit from this class, right? So you would have I stuffed up this diagram now. What did I do? Oh, there we go. Let me just grab that. You would have this thing. It would be like the ball is a public collidable. The paddle is a public collidable. Each edge of the screen of the play area would be this public collidable thing, right? And then the actual, what are those things called? Those blocks, those little blocks that you hit, like the things that stacked up that actually gives you score, those would also inherit from this collidable thing. And this collidable thing, it just has some properties in it, like it's got a direction, and it's got some knowledge of its own bounding direction. It's got knowledge of its own bounding box and direction, and it has this action that occurs when a collision is detected. And the way we detect the collisions is we have this it's like a, how can I say, it would be like this manager class thing that sits there, right? And it has logic in it that says, iterate over all of these collidable objects and then compare them to like whatever, to each other or whatever. So iterate over all the collidables on the stage. We would then obviously register our collidables with this manager thing, and that manager thing would then have the logic inside of it, the context to understand, like, are these things hitting each other. Now obviously we'd want to add some sort of, at some point we'd want to add some kind of space partitioning system. I think in this specific instance we don't need it, because the space we're partitioning is not a boundless volume. Is there an easier way to explain? It's not in just this unrelenting Cartesian system. It's a tiny little simulation. It's literally a bounded volume. Our screen is only yay big, and you can't go off the edges of the screen. Your sprites do not travel past the current bounds of the screen, nor do the bounds of the screen shift in the simulation. It is a fixed width and height that's represented at different scales on your actual monitor or your display, whatever you're using to view this thing. We are having a window into a fixed size play area, right? So the simulation is not, it's not boundless. It is a bounded simulation, and it's bounded in a very tiny fraction of potentially infinite space. Most games, like if you play my word, what game can we say? If you play Red Dead Redemption or Assassin's Creed is kind of limited, but Red Dead Redemption, Assassin's Creed, etc. Those big open world types of games, Borderlands, for instance, they play on it's a bounded simulation, but the bounds are massive, right? You could, like, I think in Assassin's Creed you could go for like an hour in a direction, or 2 hours, or whatever. In Red Dead you could literally just keep walking. Those are bounded simulations, and then you get on the opposite end of the spectrum, you get these unbounded simulations, which is games like No Man's Sky, in which the universe is, for all intents and purposes, that universe is essentially infinite. I know Minecraft, you get an infinite mode where you can just keep going in the direction and it generates stage view up the wazoo, like as far as you can go. So those are unbounded simulations. There's no finite area in which the simulation occurs. This is different from your clipping area, your clipping planes that kind of define what is the end of what you can actually see in the simulation, not where can you go in the simulation. So the bounds of the simulation on this specific thing that we're building right now are tiny. It's essentially you're playing you're playing on a, my word, it's like a 320 by 240 plane that exists in a Cartesian coordinate system. It's literally a tiny simulation. Like if it could, 320 by 240 quadrilateral that exists on a Cartesian system. If I could, let me just grab a fresh paint. If I could just show you what I mean by this is that you've got this x-axis, and then you've got this. Just do that. You've got this y-axis, right? No, I'm being silly. Let's represent it like this. You've got this y-axis, and then you've got this x-axis, and these go infinitely in those directions, right? So if you do that, it goes infinitely in that direction, it goes infinitely in that direction, we'll call that negative. It goes infinitely up, let's call that positive y, and it goes infinitely down, let's call that negative y, right? So let's just put a little blue red arrow on the positive directions, right? So let's just change the direction there, positive and positive. So wherever you see these little red arrows, those are the positive directions on the axis. So that direction is positive on the x-axis, and that direction is positive on the y-axis, and then everything on the opposite end. This is obviously the origin. Let's just put a little purple circle here at the origin. That represents the origin. It represents 0, 0 in this world. Most of the simulations, like the unbounded simulations of Minecraft, whatever, they can just continue going for literal ever. Our simulation goes where this is this height here is 240, and that distance across there is 320. That's it. So of all the infinite, like, time, space, hypersphere and hypercube, which is also called the tesseract, we're operating in like that infinitesimal sliver of coordinate space. You can here's the thing, you could actually make this number incredibly large and it would still be an infinitesimal sliver of coordinate space. It's just in this instance these numbers are literally laughable, right? These are literally rookie numbers, right? These are rookie numbers, and there's a reason I did this. I don't want to do a massive calculation. If I want to fill this space, if I want to populate this space with rectangles or whatever, I don't want the simulation to run into the millions of clock cycles. I don't want it running into the tens of milliseconds. I want the simulation to be nice and quick. So I want this thing to feel snappy, and I want to kind of just have a very straightforward, very simple conceptual play area to think about. So I think one of the first things we'll do, and this is something interesting, one of the first things we'll do is we'll define the collidable interface. So we'll define this red thing here. What I want for this red thing is, let's just take some nice black text. So this is a collidable, right? That is incredibly small. How would we ever read that? 20. 24. Okay, that's it. That is a collidable. And a collidable has a manager thing, right? Which is a collision man. Right? That is the collision man. And then these things are just the things that are based on those collidables. So I think the first thing we need to do is we need something better than just this one header file with this one namespace. So I want to do header files, add new item, and we'll call this it's going to be a header file. It's supposed to be a HPP. So this thing we'll call I want to call it entities, but the thing inside of it won't be called entities. It would be called, I'll just call it collisions HPP. The PP just allows you to have enough PP for this move. No, the PP, there's a name, there's a reason we do it HPPs. The HPP indicates, I don't think it's the formal thing, but the HPP indicates that there is a partial implementation. Yeah, the partial implementation to the PP. A header file is just a definition, or it's kind of like it's a forward declaration for a definition that you put in your CPP file. HPP file mixes declaration and definition in one compilation unit. So basically the PP stands for partial implementation, where the first P comes from the front of the word partial, and the second P comes from like 35% through the word implementation. Because why not, right? There's obviously a lot of there's like a whole complicated reason why it's done like that, but all I remember is that the PP is for partial implementation. There's an actual definition for it, like a real formal definition. You guys can just check wiki if you need to. I'm not going to sit and Google during this session. Okay, I don't go. Yes, call it game. Let's just do this namespace quickly. We do I don't want to do a pure virtual interface. I just want to do a struct because I want to have methods on them. But instead of doing a struct because I'm lazy, let's just do a class. Collidable. Class definition ends like that. Obviously the public, not capital P, the public portion of this class will contain whatever we had here. The mouse, I so much want to make the mouse collidable, but I don't want to because that is just silly. But the public portions of this class will contain the x, y, dx, dy with the height, right? So we'll literally just like smack these variables in there. So call these x, y, and I want to have like I'll have to think about it a little bit more, but I kind of want to have a getter setter thing, but I also don't want to write all that code for getters and setters. So let's just rearrange this quickly to do x, y with height, dx, dy. Because that is the order that I'm going to access these in. You'll have an x, y with an height, and a dx and a dy. So Collidable has a constructor. Okay, for the sake of brevity, right? Just for the sake of not having to type all these 50,000. I want to do x0, y0, width 0, height 0, dx 0, dy 0. This is kind of boilerplate. I should have had before, but whatever. I'll do a destructor, which it's not really necessary. The compiler will generate you one if you don't add one. It will just perform the default cleanup, which is remove these things off the heap, clean up the v table, and I think that's it. That's it. It'll remove its members off the heap or whichever allocation space it's used, and then it will destroy this thing's v table. That's the default destructor. Or does the compiler generate a stub that runs after the destructor? Whatever. It's cleanup. It's default cleanup. So here's the actual guts of this thing. We need to be able to say collided, right? So bool collided, and you'll be able to compare this to a collidable reference other, right? And this is the actual thing that tells you, did this thing hit anything else, right? So the way this would work is, excuse me, there'll be this external class that just has a bunch of pointers to this collidable thing. Oh, this is lovely. Let me show you all something quickly. We'll do a can you do this in C++ interface? Can you do this? Public interface cycle. Okay. I'm trying to think if it's this. Sorry, I know like several languages. I just want to know. Is interface a thing in C++? Yeah, you caught me watching myself. I think an interface in C++ is just a pure virtual class, right? Yeah, it's just a pure virtual class. Okay. This keyword exists in some other language. I can't for the life of me. Is it TypeScript? Does TypeScript have interface? Whatever. So this is just a class, Collidable, and it's got a pure virtual should it be pure virtual? Do I want to put data members in there? Well, it's definitely gonna have this bool. It's definitely gonna have this thing, right? And it would be a reference to this other Collidable, right? Then it means it can no longer be purely virtual. It has to declare some data members, right? So this is a virtual bool collided equals 0. So now we take that off and we make it a public. I think this does extends. No, I keep thinking I've been learning Java recently. In Java it's just extend keyword. C++ syntax is public Collidable. There. Now this Collidable has to override that function, otherwise embed declare that blah 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 is inaccessible. Why is it inaccessible? Public should be public. I should be able to access that. X is a non. Do I have to do non-static data member? What does that mean? Don't tell me it's gonna make me do this. Whatever. There's one constructor. I don't feel like going through a history lesson to understand the syntax. X. Let's just convert this to standard assignment. Let's see. Does that mount? It doesn't mount. So you can't do initialization. This. Why can't you do an initialization? Initialize a shortcut list like this. That short initialization list thing. Why can't I do that? Because it's virtually the same thing as this. You get the joke, virtually. I'm assuming that you can't access it like this because this thing has a different scoping rule to what to here. So in here, this is explicitly you're typing x equals 0, but implicitly it's actually saying this x is 0, and this is a this and a that. It's got a this and a that on top of it. So when you say this is actually two, it's actually doing this super x equals 0. But can I do that? No, you can't do that. But it's essentially doing this. I collidable x equals. It's going through this to get to the parent to get to the x, right? It's just like this funny thing going on here. So I think that this pointer doesn't exist at that stage. I don't know. I'm not gonna guess. The C++ compiler is nightmarishly complex. The language itself was fairly straightforward. It's nothing fancy, nothing asinine or insane going on there, but just some of these parsing rules for why the compiler spits out an error that is incomprehensible. Some of those rules are just not pleasant. So now this is pure virtual. It has to be overridden. There's this keyword that you can use that signals to the compiler that I am overriding this specific thing, and I think if this definition isn't found in the parent class, it issues a warning or something. If you're compiling with the W dash capital W all specified in your compilation options, it actually spits out the warning for you. So that's a big plus, right? So you've got this iCollidable thing, and this collidable takes an iCollidable. You can now compose with these things. So now everything can be an iCollidable. But the reason I wanted this iCollidable is because I want this collidable thing, when you construct it, I want to pass a pointer to a collision checker into it, so that you cannot construct this thing and leave it around just laying around freely. So you pass this pointer to this collision checker thing to it. Kind of. No. How would I do that? It's the reason I made this interface, and it's because I wanted to define that this thing takes a collision checker, right? And the collision checker, this thing gets an update function, and then it registers with the collision checker, hey, I'd like to be checked whenever you draw or update this thing. So we'll split this thing into two virtual functions. One will be a draw and one will be an update. Let's just first do the keywords for this language. Sorry, for those of you who know me, I know like 11 languages, so eventually it kind of all mashes together in my brain. And then it becomes like just crazy. Collision checker takes no arguments, has no beef. Sorry, it's like it's stupidly old like programming jokes. Collision checker just does that. It does that. Then I want a list of these collision objects, but I don't want specifically I kind of want a linked list, but not a linked list. I kind of want a vector, but also not a vector. Sorry, I'm just trying to work through the storage of this. I want to be able to say something like here's a collidable, right? And it takes a collision checker pointer call man, and in this call man add collidable this, right? That's it. And then this thing would have a void add collidable, which would be an instance of this iCollidable thing, right? So iCollidable star call, and then we'd put that call somewhere. We put into storage. Should I keep that pointer somewhere? I'm just trying to think, what would we keep that pointer in? Would it be a list? Would there be a way to say remove this thing? No. No, the core game loop was you can go through one level and that's it. So you wouldn't be able to remove it, but you would be able to set it to non-visible, right? So that thing would still occupy its x, y, and its width and its height, but that's it. That's all that colliding has, is a collision response, right? So ball collided. So if you collided this one and the other, collision response equals 0. So the collision response basically just says you all hit each other, right? So check if my bounds intersect other bounds. And here's the thing though, like, is there anything special? And this is a very interesting question to ask at this point before we solidify this interface. Right now it's kind of fluid. You can still edit, you can still change how it works. The way I expect this to work is that this iCollidable isn't a pure interface. It should just be like a collidable class, but I want to be able to compose it into other classes, and I want to declare these classes before I declare this collidable structure, because something will inherit from this. This would actually, I would change this to paddle and ball and whatever, but because this shares some common code, I would define paddle and ball afterwards, right? It's just me, I'm lazy. Do as I say, not as I do. You should compose this bit. You should do inheritance diagrams. Oh wait, didn't we do that? Yeah, you should do this. It's like UML or whatever you can do. But the idea would be that I would like to compose this. So my assumption is, because there's nothing else that happens when you collide something besides for this collision response, and this collision response obviously is this virtual void collision response override. Just tell the compiler you're interested in having a check for you that is an actual override, that you're overriding a base class. So do something. So you'll check one collision object against another, one eye collision instance against another eye collision instance, and if those two collided, if the collided returns true, then you'd call collision response on both of them. One of these collision response would be like this ball thing, I think. Another one would be like a paddle or whatever, and it would do something special depending on what it is that's colliding, right? A paddle nothing would happen, but the player would get some score. If it was the ball would change direction, but the other thing, if it was one of those little blocks that's sitting in the screen, they would disappear and add score to the player. There's like some like special relationship of things that happen. There's some special thing that can be defined. So the first thing I want to do is I want to say that because this class knows its data members, and these data members are set outside, right? I want to say that this iCollidable, this collided function, because of the generic nature of the way this thing is designed or defined, I would hazard that this would not be pure virtual. This would have a function body, right? And it would be final, right? I would then forward declare this and make it a friend here, and then stick this collided into protected. So is it private? Is private more than protected? Let's just see. Let's just see if I'm losing my mind, right? So obviously the first thing I need to do is return something, just something, right? So bool collided, return false. Why is return mode? Don't know. And then I would put as I'll just for declare this thing, and then make this a protected friend, right? And then the collision checker gets this list of collidables, and then in its update call update, assuming it takes a dx and a dy or whatever, it goes through its list of collidables. So I guess this just answered my question. I'll use a std vector for this. It's just std vector of pointer. I know this reallocation and all this garbage is like if you're doing long-running tasks, it basically stops the world so it can move memory around. It's not async safe unless you put manual locks on it. I know. Std vector. There's a lot of stuff going on in std vector that not to blame the standard library, but because this is forced to be generic, you kind of have to live with a lot of extra code that deals with like boundary cases and edge cases and templating and all that kind of thing. Again, once it's compiled, you don't have to worry about it. But there's a lot of stuff going on in here that I would rather avoid. Like if you, what's this? If you just look at this, the header file, there's so much going on here, right? There's a bunch of generics. There's a bunch of like memory management in here. There's a bunch of so much. Whatever. Let's just power through. So this thing would have a std vector of this thing pointer. Let's just get rid of this space very quickly. Collision objects. It shouldn't actually be collision objects. It should just be entities. It's an ECS. So you're doing entities. So entities dot push back call, right? And the reason we do this is because we can be guaranteed this thing would be called only once, and we don't store that pointer anyway. We just leave it there. So you can now no longer override this bool, right? And now it moans because it says you're overriding. This is the reason I use this override keyword, because I'm saying override. It's intended to override something, and the compiler can flag you and say, but hey, there's no such thing as a publicly available override for something like this. I can take this off because now there's no more compiler, right? Nice. So that's it there. So now I want to go for int I equals 0, I is less than. How would I check each one against each other one? You'd have to do a doubly nested loop. I is less than entities that size I plus plus. How would I do in current entity IDX if it collides with something? Well, I want to do a do while. Do this thing, which then includes an increment, right? Plus plus current entity IDX while current entity IDX is less than entities dot size. There you go. You are welcome. I've taught you how to use a do while loop. If you put while up here, then whatever. There's a reason it's called do while. Do this thing and then increment this thing while this thing is less than that thing. Nice and easy. I know that's not the best motivation for the do while, but the logic tracks in my brain. Like, do these things and then do the check, right? Because I know the first time I go in here, I want this thing to be 0. I want it to be the first entity, right? So all we do is we say if current entity IDX equals I, then continue, because don't check an entity against it self, right? Simple as that. So all you do is you say if entities I dot collided with entities current IDX, right? Why is this thing burning? Oh, you can't cast that to a star because this thing is taking a reference. I actually want a other constant pointer other, and it's non-const, so let's just treat it as if it's constant. So easy. We'll just be very careful to not modify things inside there. So if they did collide, so if this check returns yes, these two things are touching, then all we do is oh, here's an interesting question. What do you do in this instance? So if entities I collided, then entities I dot collision response, which takes nothing, and entities current entity IDX collision response, right? And I believe for this update cycle, if we've called the collision response on both of those entities, then your game runs. It's got an update cycle. Each update cycle, it goes through this update loop, and the first time it finds any two things that hit, because everything else on the stage is non-static, the only thing moving around that could potentially hit things would be the ball. So the moment it finds anything that hits, it calls the collision response handler, which does something for the ball and does something for the player and does something for the top stack of the blocks. But that ends your collision check. That should break you out of that cycle. So at this point you should return, right? Return early so that you don't continue checking because you've already hit something. There's potential to hit multiple things, but we're going to try and avoid that instance. In any case, the very next update cycle, the next frame it paints, which again is too quick for our perception to actually go and see unless we slow it down physically. The very next frame it would check, it would if your ball is touching block A and block B, this first check would check from left to right, and it would find block A, and it would say yes, collision response, this thing and that thing. The ball would then change direction or whatever, and the very next frame it paints, before the balls actually had an opportunity to move, it would check, hey, did I hit block B? Maybe, yes. So you hit block B and it says collision response, and it does something to block B and it does something to the ball, and that's it. That resolves, right? There's one frame's worth of lag in doing it this way. Collision response both, and then return early. So you incur 1 frame penalty of accuracy in the simulation. I'd say that's a fairly good trade-off. Like, I haven't seen great trade-offs like this. I play some online multiplayer games. The prediction algorithms they use for server-side prediction is insane. Client-side prediction is fairly straightforward. You've got all the inputs immediately available to you. You can just say, well, this guy's pressing right. He's probably going to keep going right for like the next 3 frames because that's the lag on your input. Incurring a 1 frame a penalty on a potential misprediction is completely fine. This isn't actually a misprediction, this is just examining the state, but this collided potentially holds the incorrect state for 1 frame, because there's a potential that you've collided with 2 separate things. You could collide with the block and the wall. Say you got a block at the edge of the screen and the ball hits exactly in that edge. You could potentially hit the edge of the screen as well as the block, both in the same frame, but it will resolve whichever we're checking first. If we first check, did you hit the stage, and then did you hit the blocks, it would first resolve the stage collision, which misunderstands the simulation for 1 frame. The very next frame it comes through here again and says, hey, did you hit the stage? No, because the ball has moved, the update loop has run, right? The collision response would move the ball. It says, nope, I'm not hitting the stage, but I am hitting this block, and then it does a collision response, which then hides the block and changes the direction of the ball. So you've got 1 frame worth of lag for accuracy, and I think that's a fair trade-off, right? So you've got this thing that sits there, it increments this thing. This thing just checks that this is all correct. If it's not, it just breaks out and does nothing, and if it does hit something, then return it. So you've got this collidable thing. I'm not entirely happy with this, but let's say you do this collision checker. It says, did this collided? If it didn't collide it, this just incurs the penalty of a doubly nested loop like this, which is fine. I expect to have like maybe 300 items on the stage. It shouldn't be difficult, and if we keep this bool collided function sane, then we should. Oh my word. Oh my word. Where is the thing that checks if the... I think this is the test between something and other thing, right? Oh, no, what did I do here? Oh, Control C. I think that's the test between something and other thing. Let's just check. So if this x plus this height is greater than other y, oh shoot, this collidable does not have... oh, I can just do this, just put the protected stuff afterwards, right? So just do public and then protected, and now it's got an x and y with... yep, here we go. And y is less than other y plus other height. Wherever I see ball x, I'm just going to substitute for this x, right? And wherever I see paddle x, I'm going to call it other x. So wherever I see ball, it's just this, and wherever I see paddle, it is other, and a dereference, right? Just so you know what I'm trying to do here. So let's check. So if this y plus its height, which is the bottom right corner, is greater than the other thing's y, yes, and this y is less than the other thing's y plus the other height, which means it's within the range of this thing, and this thing's x is greater than the other thing's x, and the x plus width is less than or equal to the other thing's x plus width, then we definitely, some point of this thing is inside that what's his face, right? Great. So something's wrong. If you see an opening brace like this on this line and you don't see a closing brace on the same line, it means something's wrong. So let's see, I opened an if statement. Where does an if statement terminate? There. So it means I'm missing a brace. There we go. So this return false should be the fall through case. It should leave the if statement and then return false. Okay, so then default is if you don't do anything in the if, return false. If you do something in the if both of these conditions are satisfied, there's actually 4 conditions there, all 4 of those conditions are satisfied, return true. So now you've got a way to say, did these things hit each other in a very generic manner, because again, the simulation assumes everything's a rectangle, and it assumes that the rectangles only have a positive surface area, so that's fine. This initialization I don't actually want to put there. I'm willing to bet like physical monies that this interface I need to flip the responsibilities of this interface. I should declare this eye collision checker. No, you cannot be a friend of an interface. Maybe you can. I want to get rid of this like weird inversion thing. I don't want to for declare here. I don't want to have to do all this like weirdness. I want to be able to say like, and I guess the reason is because I want this, right? I want this. I want this thing to just be there. It shouldn't be there, but I want it to be there. I want this collidable thing. I want so badly for this collidable thing to internally manage its allocation into this global list. That way you can't have collidables that don't interact you can't have collidable objects on the stage that do not interact or take part in the collision detection loop. This thing here that we've written here is called a collision detection phase in the game. I don't want to have entities just laying around that don't participate in that phase, and I so badly want them to partake of that collision detection beauty. So I want there to be a way for an entity that if you construct something that is collidable, it just by default goes in the collision manager thing. So let's think about it. I've had a long day, I'm super tired, but let's think about it. We've got a couple of minutes left. Let's think about it. So you got this collision checker thing. It is the friend of your iCollidable, right? Collidable interface. This iCollidable doesn't know what this collision response is. It just knows that something needs to happen. So you have to override, you have to subclass that thing with a default collision response. But this means that this thing specifically isn't actually a collidable, right? This thing is actually a collidable, right? So this would be, here's a collidable, it has a collidable other. I've got a list of collidables, and a collidable adds itself to me, right? Let's just save, see if that goes away. Okay, oh, right. And then this would be a paddle. This would be a concrete implementation of that, which is the public type is now collidable, right? So this thing then knows I'm a paddle and I'm a paddle, and my collision response is do something, right? That is how that would work. But I want that in force. I want that. I want this. This enforcing this constructor. I want this to actually live at a different level. I want it to live here. This is the conundrum. So what we would most likely do is, since this thing needs to understand, this collision checker needs to understand this collidable thing, right? You'd have to for declare it. But you don't necessarily need to for declare it. I'm thinking, and here's the actual reason you could do an interface. You could do an abstract raster because there's like an iCollision checker. It has this interface in it that says I know how to add a collidable, and it takes this collidable pointer. And you make it pure virtual. So you would do, oh, is this gonna work? iCollision checker, and it has this function in it, add collidable, right? You just have this class collidable for declaration, add collidable. That is pure virtual. Make it pure virtual, and then this collidable thing. When you, let's take the public interface for this thing would be collidable. It would take this iCollision checker pointer, call man, and in this thing it would do call man add collidable this there. What is it moaning about? It's inaccessible because it's not public. So now this collidable thing has a friend that is an iCollidable, iCollision checker, and this collision checker is just public that thing, iCollision checker. Let's see, and now it needs to add collidable. Why is this not? It's inaccessible, but I have a friend that is a collision checker. Why is it inaccessible? Does friends not operate on base classes? Let's just see, C++ friend class. I would very much love to know, does it allow you to friend based on the base class, right? Can you inherit friendship? Oh, yeah. C++ can friendship be inherited? So such an easy. Oh! You cannot inherit friendship in C++. Well, this is not the thing I was working on. This is something totally different. So now we grapple. Ah, they're blocks. Now we grapple. So now I still need to have a friend. I love these little problems. I obviously know a better way to solve this, but I love these little problems. Just want to see how far, how convoluted can you make this. So now you can friend that collision checker thing, right? So is there a reason to friend this thing? No, there's no reason to friend that thing, right? As far as I understand, there's no real reason to friend that thing. So this paddle thing now wants. So if we just look at the, I'm running out of time. If we just look at this, there's this collidable, this collision checker, right? The collidable takes an instance of this I collision checker, which has this interface thing that does some stuff. And the reason is this problem solely exists because I want to define everything in this one header file. I don't have like a common header file that does these functions and then an implementation header file for each thing. So I want to define everything here, and I wanted to just compile in order and find every for declaration and match it up with the definition that occurs later down in the file. And then I want these interfaces, even though they're not how can I explain? Excuse me. They are not globally available and globally defined interfaces. They are not meant to exist outside of the scope of this thing. I want the interfaces to do something useful, right? I just call this I to call it interface. It's interface to collision checker, and all this thing needs to be able to do is add a collidable, and then I want this thing to be called check collisions, right? That's actually what it does. It's just a void. It doesn't actually do anything. So I want a virtual void check collisions, and it's pure zero, pure virtual. So now we got this interface, and this interface does I collision checker, knows how to add a collidable, and I have this collision response function that does something. I've got a friend that is a collision checker, which I'm not too happy about. So now this, well, it's fine. The concrete implementation of this thing knows about the concrete implementation of that thing because it's a friend, so that the friend can access this protected bool collided, right? And this protected bool collided, the reason I put a protected bool collided is because I don't want the other classes to be able to override this. I want this to be just this little sealed black box of there's a way to check a collision. So if I find that, oh, this is grossly inadequate, and I change this to this is called AABB, axis aligned bounding boxes on the hillside made of tiki-taki. This is axis aligned bounding boxes. These assume that these things are aligned, that the sides moving up, the left and right sides are parallel to the y-axis, and the top and bottom sides are parallel to the x-axis. They are axis aligned. To simplify the calculation, you'll see that if there was slope involved, you'll have to actually go and calculate the intercept of a point against this line to determine if it's actually hitting. So the way to simplify that is to make sure that everything's nice and perpendicular, because then you can check the top left corner and the top right corner and bottom left and bottom right corner, and everything's just happy, right? So the concrete implementation of this class knows about the concrete implementation of that class. This interface just defines, here's this a thing that must be overridden in order to actually function. So the add collidable, if I wanted to change this, see, if I want to change this, if I want to change this to contain a linked list, it's fine. It's a sealed interface. I'll just use it as is. So now I can add these collidables, and I've got this like collision response that has to happen, and I've got this pool collided thing that knows what it needs to know. Now I've got this add collidable into this pushback, which just it's a concrete implementation of collidable, and now here's a paddle. This is an actual collidable. So now the thing I wanted was, why does collidable not just do this on its own? Why does collidable not just have that in it, right? Because this collidable now has code in it. Why can't it just do that? Which is what I originally wanted. In case you didn't know, the reason I've been thinking so hard about this is because I wanted this originally. I wanted to be able to say, here's some default initialization for these things. It happens on its own. You don't have to care about it. There is a well-defined way of determining if this object is valid or not. You just check if the width and height are 0. All right, very easy way of checking it. In fact, if the width or the height are 0, then this object is not valid, right? So here's a collidable. It enforces this thing. You cannot get a collidable instance without it being added to this collision checker, which has a concrete implementation here and a concrete check collision. So virtual. So this would then be to allow you to override it further if you need it. And I want to mark to the compiler that I'm overriding something. So if I change that interface to now be a reference or pointer to pointer, doubly must directed address, then it will issue a warning to me to say, hey, look, this doesn't look right. You said you're doing this, but you're not doing this. So, go look at your code, right? So it's very nice. So yeah, this cannot be default constructed anymore, but because this thing is the paddle, this represents the player, right? Let's just get these names right from step 1. Let's get all these little component things to do whatever they need to do. So this is a public collidable, which will take that call man. So now the paddle is fully constructed. You now have an instance of the player which is fully constructed. And the nice thing about this collision response is you now know, does the player hit is handled somewhere, right? If the player hits something, right, we need to know what did it actually hit, because the collision response for a player hitting a wall is different from the collision response from the player hitting a ball, isn't it? The player needs to be checked against the bounding volume of the finite simulation area. So the player can only move in one plane, although it would be amazing if we could make him move around and bounce off other things, which again there's potential to do it. But let me just move quickly, just based on the time here. So if your player hits this thing, he stops, he kind of bounces off the edge, right? So the collision response of hitting something would be different from the collision response of hitting something else. So this collidable would have to have something that's pure virtual, right? and the pure virtual nature would be virtual int get type. Right. So now this get type function, everything that matches the same type don't collide with each other, right? But you could define here, especially here, you could define, is this get type of a ball or wall or whatever. In fact, let's go a step further. Let's just do an enum collision type wall is 0. Wall would include the top and the bottom, so walls all around the bounding volume. Then there'd be player. You don't need to do that. It'll auto number, the compiler will auto number this, and then it will be ball, and then it will be brick, right? So now you've got this collision type. So when we say collision response, your entities would respond to each other. So you'd collision response with a collision type, right? Yeah. And then this virtual get type would actually just be collision type get type. So your wall and the player hit, and the wall would get a collision response player, and the player would get collision response wall. So this way we can actually check inside the player. What do I do if it's a wall? What do I do if it's a floor? What do I do if it's a ball? So if I do a collidable with a collision type and a collision type get type, let me just first and foremost just get these types. It does complicate this because now there's this fixed list of types. We can talk about this. We can do some. I don't need to compile time magic. I want all the magic to happen at one time. So let's just power through collision response. You get collidable other. So if collidable other, so yeah, entities I collision response. Yeah, right. Collision response get type. Boom. And then this entities blah 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 collision response other get type. That solves one problem, right? But now it does mean that these things, when you say go get me the type, collision type, when you say collision response type T, this is the type of the other, right? So there's something missing. I cannot instantiate a paddle because my get type function is pure virtual. I need to override this thing, and I need to make sure that everything that should be say override says override, virtual override, yeah, and then virtual collision type get type override turn, and now when it return, this is a player, right? So return player. There is now some cognitive load in this. Unfortunately, sometimes you cannot. Hey, compiler, I'm typing. Just format on top of what I type. And in Soviet Russia, compiler type you. It's been like a stupidly long week. So yeah, collision response. So, and here's something nice. You can now define. This is the nice thing about this. You can now define here's a wall. Right? So I got a class. The bounding volume will just consist of 4 walls, right? Common, collidable, wall. Get type return wall, right? And here's the nice thing. What is the collision response of a wall? Like honest to goodness, what is the collision response of a wall? If I go bang my head against this wall, like just here, if I go bang my head against this wall, what is the collision response of my head? It's like, I don't know, like bleed, hurt, become concussed. I don't know. But what is the collision response of the wall? Nothing, right? This pure virtual function is just a lovely stub here that just sits there and says, hey, it's a wall. What do you expect me to do, right? So the wall definition becomes the simplest of all. It's the constructor, the destructor, and these two virtual methods, one of which returns a type that indicates that this is a wall, another one which just kind of sits there to complete a v table. So this is lovely. I don't want to add a default for this because each type has a unique collision response, but the collision response of a wall, this is the reason I went through this whole thing. The collision response for a wall is nothing. The collision response of a player is different depending on whether it's a wall or a ball or brick or whatever, right? And then obviously, actually I want this to be a little bit, yeah. The collision response of a ball is also different based on whether you hit, well, they shouldn't be called collisions, they should be called entities, but let's just call it collisions because the main aim of this was just a thing that could hit other things. You can now compose a player has some other state that you can add to it or whatever. But one of the interesting things I wanted was that you now have everything you need to define the ball, right? The ball is now part of the collision detection scheme thing, and its type it returns is ball. We just need to be very strict with these types, checking these types, making sure that we don't return player for a ball. Sorry, the baby is very unhappy about something. Collision response for ball is obviously change direction. If it's a wall it hit, it figures out which side of the wall it hit and then changes direction. There needs to be some more stuff we add to it to understand what's going on, but I think for now we'll actually collision response. This check collision thing, we'd have to return a side that hit, right? Brick and brick. So this thing returns a type of brick. Here the type is brick, and we now have a workable system for understanding which things hit which. Right, very nice. We obviously don't do anything when this thing happens here, but now we can go in here and say include collisions, right? And now we don't have this weird like those things. We just that's out. What we do have is a the simulation contains 4 walls. It's the top, the bottom, the left, and the right. So you got an array of walls. How do you default construct that thing? Right. We'll get to that. How do you default construct the walls? I'm very curious. I'd say we just have a wall pointer walls. We'll manage memory for that at some point. We got the walls. We've got the player, the panel, which is the player. We've got the ball, which is the ball, right? And then you've got a bunch of bricks, right? So you got to point it to bricks. So you got a wall and bricks. So brick, star, bricks. Okay, so now you got the walls, you got the player, the paddle, the ball. You also now need, in order to be able to compile this thing, you need this collision checker thing. You need the concrete instance of it so that you can pass it in. So you will need a collision checker, right? So this collision checker, luckily it doesn't take any special arguments, so you could just have a doof. Here's a collision checker member. This collision checker call checker. I want that to be camel case. And I got a collision checker. So now let's ignore all this. Oh, there's so much going on here. Oh, lovely. I already had some kind of end commentary. So yeah, when you construct a simulation, you now need to pass this collision checker, right? The address of this collision checker. Sorry, you need to pass the address of this collision checker into the walls and the bricks. We'll construct one by one. Yes, it's an array. It's an array. It's an array of pointer. just curious. Would we malloc and then go through each one and say new wall? Let's do that. Let's fiddle with malloc. So the player, let's construct the player and the ball. The player and the ball now require player and call trigger, and the ball now is required and call trigger. Right. Okay. So now you've got those constructed. Excuse me, I'm having a little bit. Okay. So yeah. Now these. Sorry. Now these things have like update to draw and whatever function, which we'll get around to this. We'll figure something out for this. I just want to have the same thing for it. So I want walls to equal new array of walls, right? So yeah, walls equals new wall array 4 walls. Do you just pass call checker into it? Does that construct me 4 walls? A new initializer. How do you construct new? It requires C++ construct C++ new array with arguments. I can't for the life of me what parameterized constructors. There we go. I just can't for the life of me think what that syntax would be. So I've got this thing and it takes x and y. So now when I say new something, malloc and thing. Okay, so there's 2 ways to solve it, and this is the reason. This is the main reason why I mentioned malloc and then new each one. So you got a wall star wall. You can this new thing just reserves memory for it. You still have to go through each one and say this instance equals this value. So yeah, you do walls equals malloc 4 times size of wall, right? And yeah, you just make it a wall star, right? Wall star. And then you'd say 4 into w equals 0. W is less than 4. I'm not even going to name that thing. I just know there's 4 walls. So I just want to do int num walls, right? So you do num walls times size of that thing. W is less than num wall w plus, and then you say walls I equals new wall, and now you can pass your stuff in there, which is ampersand colon there. Now each w equals collision manager call checker. So this is how you would traditionally do it, right? What is this money worth? I want to list the wall star. You gotta be joking. No. I want the array of wall star. Oh, it's just crazy. Wall star array. Could it be that I could say walls equals new wall star 4? Would that work? I love fiddling with the syntax. It's like my all-time favorite thing. And then each one in there becomes new. Does that work? I want an array of star. Unfortunately, it's gonna have to be wall star star, right? I think this is the only way that's gonna actually work is if we make it wall star star. Yeah. So there. New wall star 4, and then for each one you construct it. This is horrendous. I understand now why people just go for std vector. In std vector, you'd say I got a std vector of wall star, and then for each you just say for however many times I'd like to add walls to this. You just push back new wall, right? Easy. But since we've already written all this code and it's running into like an hour and a half, let's just do the thing. I got new wall star. So you got 4 walls. I'm not gonna do bricks, so I'm just gonna do player and ball. I think I've done player and ball. Can I access player and ball X, Y with height? I think I can. Let's just go in here. X, Y, it's public, so I can just access it. So let's just do player.w. So you do player dot right equals static cost float with height, and then this is player dot and then this is ball dot x dot y, dx dy width and height. So now you got walls and you got a ball. Obviously the ball is just going to keep going like in perpetuity if we don't do anything with it, but this is how you would construct all of that weirdness. Here's how you construct all the walls, and now you say great, I want to like do the initialization for the walls, but I don't think I have enough time to type all that weirdness out. Wall 0 is just going to be -1. Just 1. Actually, you could just make the wall like 2 pixels thick all around. So it will be 0, 1, 2, 3. So walls 0 x equals 0, right? Y equals 0. Oh, again, this is walls 0. Wall 0 width equals 2. It could literally just be 2 pixels, but walls. Oh, actually, I would make that a lot wider, because there's a potential that if your ball is going faster than 1 pixel per frame, it could actually go through the wall. H equals H, right? So this is the left wall. And then you want a right wall, a top wall, and a bottom. So left, top, right, bottom. Top wall, right wall, bottom. So this is 1. That's 2. So the top wall, the x is 0, the y is 0, the width is width, and the height is 2 pixels. The right wall, the x is width minus 2 pixels, the y is 0, the width is 2 pixels, the height is height. And the bottom wall, the x is 0, the y is height minus 2 pixels, the width is the entire width of the screen, and the height is 2 pixels. There, done, got all the walls sorted. Obviously there's still what's this thing, bricks and all that garbage. Let's just ignore those. You create compatible bitmaps, you select, now you update in draw. So now you want to do, oh, this is nice, you just change a bunch of stuff here. Oh, it's not battle, it's player. Why does it rectangles not have a space thing? Huh? Like, why is it formatted so poorly? Oh, no, not the player. Yeah, there we go. So again, ball.x, ball.y, ball.x plus ball.width, ball.y plus ball.height, draw. Right, boom, more drawing code here, drawing code there. I want to draw the walls, right? Do I have anything besides a red brush? No. Okay, so draw the walls first, right? So for I equals 0, I understand. Num walls should be like this, hash define. Let's just do hash define num wall is 4, right? And I'll show you now why I did this hash define thing, so that I can just do that. That's a const now. So, oh, there's no way to do a. I would love to know what is the syntax, and this is something I should be ashamed that I don't have the syntax for it. But what is the syntax for if you've got an array of thing that doesn't take a default constructor, right? I plus plus. Right, is now the I in this. Yep, now the I in this functions. Now I do that. I got this rect. W equals walls I X. Is it? Full rect DC and W. I think that is it. I think that is how you do it. So obviously now we've taken up we've reduced the bounding volume of the game area by 2 pixels. So you should see like a red border around the playing area, right? So now we've lost the ability to move these things around. We don't have a collision detector or anything. So first, let's see, does it compile? I've got like 30 seconds to see if it compiles and runs. Great. Yeah, it doesn't move around anymore. But now we have a bounding volume with a playing field. I'm super happy about this. This means we can now start moving these around, and I think we'll move these around in the next video. We've done plenty enough to be able to say that in this playing area we now have this collision volume, and these entities here, these things are collision objects. This is literally how platformers work. Those little blocks you stand on are collision objects. And this thing detects there's a collision response that happens. I think in the next video we'll tackle the collision response, get the stuff moving again. But I'm super happy that we now have a bounding volume. We understand a little bit more now the finite nature. I'm going to reduce this width a lot, or I'm going to set it off the screen so that you can't see it when it's rendered. Maybe you see 1 pixel sticking out, but it's distracting. Maybe I can fill it in with black, or I can just not render it. But I think for now this is I'm super happy with how this came out. We've got our xy with height dx dy. We can now be convinced that we've added them into the collision manager, because you can't create this thing without doing it. Also, this incredible amount of weirdness here with full declarations and collision types and whatever. This is all nice. We now got a fake stupid ECS thing going that kind of gets us this overridable collision response, that you, even if the response is the same for multiple types, which they're not, this is the reason I did this. It's the collision response for different types are different. Walls are the classic do nothing collision response, but then in response to a wall, a player would stop moving, a ball would bounce, right? A brick doesn't detect the wall, it just does nothing, it disappears when you hit it with a ball. If you hit the brick with anything else, do nothing. But yeah, your check here would be, if this is a brick, if you hit it with a ball, then the visibility of the brick changes. I guess you now need to override or add a public member to this brick that has a visibility. But that's all for the next video. I'm super happy. We have a drawable bounding volume that we spoke about earlier. We've got this finite volume. We can now draw the bounds of this volume by only drawing the collision object that it's detecting, or that we've set up for this. We're now drawing only the collision object for this volume, which creates bounds, and then we can draw the x and the y. I suppose we could do the axes, but for now we can draw the ball and the paddle, which are no longer this weird set of not there, yeah, which is no longer this weird set of just random integers thrown together. They now belong to actual objects, composed types, and those types are now primed for if we need to do stuff like funny stuff like, hey, let's change how some piece of it works in a very integral manner. Then we just go in the setup file, we add a piece of implementation, and then we're happy. I think I'll clean this up a little bit, maybe split these into separate files. I don't think so, but maybe split these into files. Definitely want to clean up a bunch of these comments in this file. This file. Definitely want to clean this up. There's a lot going on here, but I think we'll stop here for now. I'm super happy with this. That takes us to the end of our journey for today. It has been like just over an hour and a half, and I am incredibly tired. So for this week, we went from, hey, here's a ball that moves around, to, hey, here's a screen with like a bounding volume and a collision detection mechanism algorithm, blah blah blah. And next time we'll go in there and we'll do all like the fancy things. We'll make it do all the stuff. But for now, I'm super happy with that. Got a fake stupid ECS that doesn't actually E or C or S yet, but it does have the C. We got the C. We don't have the E or the S. Even though the C, we call them entities. We called the E the C. Cheers, guys. Have a lovely weekend. Don't forget to like, comment, subscribe.